Welcome to this tutorial on Spring Boot with Kotlin for enterprise backend development. In this series, we'll explore how to build production-ready APIs using the powerful combination of Spring Boot framework and Kotlin programming language. Kotlin has become increasingly popular for backend development, and when paired with Spring Boot, it offers an exceptional development experience for creating robust, scalable applications. Let's understand why Spring Boot and Kotlin make such a great combination. First, Kotlin provides concise syntax, which means you can write less code compared to Java while achieving the same functionality. This leads to higher productivity and faster development. Second, Kotlin offers built-in null safety, which eliminates null pointer exceptions at compile time rather than runtime, making your applications much more reliable. Third, Kotlin has full Java interoperability, meaning it integrates seamlessly with the entire Spring ecosystem and existing Java libraries. Finally, Kotlin brings modern features like coroutines for asynchronous programming, extension functions to add functionality to existing classes, and data classes that automatically generate common methods like equals, hashcode, and toString. Let's set up our Spring Boot project with Kotlin. In the build.gradle.kts file, we need to configure several plugins and dependencies. First, we add the Kotlin JVM plugin with version 1.9.0 to enable Kotlin compilation. Next, we add the Kotlin plugin.spring, also version 1.9.0, which automatically makes Spring annotated classes open for inheritance, as Spring requires. Then we include the Spring Boot plugin version 3.2.0. In the dependencies section, we add Spring Boot Starter Web for building web applications and REST APIs, and Jackson Module Kotlin, which provides support for serializing and deserializing Kotlin classes to and from JSON format. Now let's create the main application class. In Kotlin, the application entry point is much simpler than Java. We create a class called application and annotate it with that Spring Boot application. This annotation enables auto-configuration, component scanning, and configuration properties. Below the class, we define a main function that takes an array of strings as arguments. Inside this function, we call runApplication with the application class as a type parameter and pass the command line arguments using the asterisk operator, which spreads the array. This single function starts the entire Spring Boot application with an embedded web server. One of Kotlin's most powerful features is the data class, which drastically reduces boilerplate code. Here we define a user data class with 4 properties. The id property is of type long and nullable, indicated by the question mark, because it will be null before the user is saved to the database. The name property is a non-nullable string representing the user's name. The email property is also a non-nullable string for the user's email address. Finally, the role property is a string with a default value of user, meaning if no role is specified during object creation, it automatically defaults to user. The data class keyword automatically generates useful methods like equals, hashcode, toString, copy, and component functions for destructuring. Let's create a REST controller to handle HTTP requests. We annotate the class with a trust controller, which combines @controller and @response-body, automatically serializing return values to JSON. We also use @request mapping with the path/API/users to define the base URL for all endpoints in this controller. The controller uses constructor-based dependency injection to receive a user service instance, declared as a private val property. We define 2 endpoints. The first is annotated with @getMapping to handle GET requests and returns a list of all users by calling service.findAll. The second is annotated with @PostMapping to handle POST requests, accepts a user object from the request body using @requestBody annotation, and returns the saved user by calling service.save. Notice how concise Kotlin single expression functions are compared to Java. The service layer contains the business logic of our application. We annotate the class with @service, which marks it as a Spring-managed service component. The user service class receives a user repository through constructor injection. We implement 3 methods using Kotlin's single expression function syntax. The findAll method returns a list of all users by calling repository.findAll. The save method takes a user object and persists it to the database by calling repository.save, returning the saved user with its generated ID. The findById method takes a long ID parameter and returns a nullable user, indicated by the question mark. It calls repository.findById, which returns an optional in Java, and we use or else with null to convert it to Kotlin's nullable type. This service layer acts as an intermediary between the controller and the data access layer. The repository layer handles all database operations. In Spring Data JPA with Kotlin, we create an interface that extends JPA Repository. We specify 2 type parameters. User is the entity type we're managing, and long is the type of the entity's primary key. By simply extending JPA Repository, we automatically inherit methods like save, findAll, findById, delete, and many more without writing any implementation code. Additionally, we can define custom query methods by following Spring Data's method naming conventions. Here we add 2 custom methods. FindByEmail takes a string email parameter and returns a nullable user. Spring Data automatically generates the SQL query to find a user by email. Similarly, FindByRole takes a string role parameter and returns a list of users with that role. Spring Data intelligently translates these method names into appropriate database queries. Proper exception handling is crucial for enterprise applications. We create a global exception handler by annotating the class with @controller advice, which allows us to handle exceptions across all controllers in a centralized manner. Inside this class, we define a method annotated with @exceptionHandler, specifying resource-not-found-exception : class as the exception type to handle. The method takes an exception parameter and returns a response entity containing an error response object. Inside the method, we build a response entity with HTTP status not found using HTTP status.notfound. We set the response body to an error response object, passing the exception message or a default message of not found if the message is null, using Kotlin's Elvis operator. This approach ensures consistent error responses across the entire API and improves the client's ability to handle errors gracefully. Let's recap the key takeaways from this tutorial. First, Kotlin reduces boilerplate code significantly compared to Java, with features like data classes, single expression functions, and smart type inference, allowing developers to focus on business logic rather than repetitive code. Second, Kotlin is type-safe and null-safe by default, catching potential errors at compile time rather than runtime, which leads to more robust and reliable applications with fewer crashes in production. Third, Kotlin provides seamless Spring Boot integration, working perfectly with all Spring annotations, dependency injection, and the entire Spring ecosystem while maintaining full compatibility with existing Java libraries. You are now ready to start building enterprise-grade backend applications using Spring Boot and Kotlin. Happy coding!
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.